For the second problem, we will have a circuit shown in the figure when the switch is open, and also initial the capacitor to be empty. For question A, it asks to find the reading of each ammeter and also each voltmeter just after S is closed. So when it says just after S is closed, so the times will be 0 seconds. When times is 0 seconds and the capacitor is empty, the circuit will go this way, the current will go this way, like this. It will not go through the inductor. And so if it's not goes here, the voltmeter V2, V3, and also the ammeter A3 will be all 0. So these three will be 0. And if goes through this way, it just be a series. So the current in the circuit will be the power of 40 volts over the two resistance here, the 50 ohms here and 50 ohms there. So the current in the circuit will be 40 over 100 will be 0.4 ampere. Once we get current here, it's because it's a series, so A3 will equal to A1. They are just 0.4. And once we get current here, the V1 will be the current times the resistance here. It's 20 volts, and also the same in V4 here. It's also 20 volts. For V5, it's 0 because the capacitor is empty. The current just goes through the capacitor to charge this capacitor. It will not go through the voltmeter. And for question B, it says find the reading of each meter after a long time has elapsed. So after a long time, it means the capacitor and inductor will be both full for now. And if the capacitor is full, it will not go to that way. It just goes through the inductor. And so if it's not goes through there, V5, V4, and A3 will be 0. And A3, V4, and V5. And also because the inductor is full, and so the V2 will be 0 also. And it's also a series, so the power 40 volts over the two resistance here. The first resistance is 50 and the second is 100, so we can get the current is 40 over 150 will be 0.267 amperes. Once we have the current in this series, V1 and V3 will be easy to get. They just times their resistance will get the volts. For problem C, it says find the maximum energy stored on the capacitor and when it's occur. If it needs the maximum energy, so it means the long-term close the switch, and we use the equation relate to the capacitor. The energy is equal to capacitor times the volts square over 2, and we just plug in the numbers. The capacitor will be 12 times 10 to the negative 6 and the V square, and we'll get the energy. And it will happen after long time of closing switch because the capacitor will be full. And for question D, it says find the maximum energy stored on the inductor and when this is occur. It will be the same. It will happen after a long time of closing switch, so the conductor will be full as well. And the equation is related to the conductor. The energy is equal to it's inductor times the current square over 2, and also plug in the numbers 5 times negative 3, and the current 0.267, and we'll get energy. For question E, draw a graph of reading of voltmeter V2. And for question A, it occurs when the T is equal to 0, so we will know V2 is 0. It should be 0 here. And when it's charging, the volts will grow, and we have the question here when it's for a long time. It means the V2, so it's inductor will be full, and for that time inductor will be full, so V2 is also 0, so it goes down when the inductor is full.